Thank you. Good morning. My name is Frederico Simões. I'm a PhD student here in the University of Valladolid. And today I want to call the attention for the artificial intelligence and how this is changing the way we live. When I was writing this presentation, I tried not to link the human intelligence with the artificial intelligence. And I wrote several sentences trying to split them, but it was impossible because like some decision making is emotional and some kind of that we are proud of, human beings. The computer, it's also, if you well train it, it's also possible to have some decision. So in 2004, John McCarthy, he defined this definition for artificial intelligence. It's a science and an engineer of make intelligence machine and system. And it's well accepted, but this one seems to be more feasible. Artificial intelligence is the technology of using which we can create intelligent system and can simulate human intelligence. So it's impossible to not link both. And by the way, all the images I'm using, almost all the images, it's made with artificial intelligence. Since the first industrial revolution, things are changing the way we do, the way we manage. They're changing the rural lands, the way to produce, and the transportation, communication, building new products derived by petrol. And nowadays, we can say that we are in an internet revolution. So many computer programs, development of intelligent things, it's been under development and it's changing the world. And here we have a graph, the upper one, it's related to the number of papers published using some kind of artificial intelligence. We can see in 2020, it's missing the last 2 years, it's increasing. Sorry. And below, there's the graph. I searched this graph in Google. It's related to searching on Google, where people are looking for artificial intelligence, deep learning, machine learning. And we can see this evolution. It's an interesting thing that it's not necessarily only in the rich country that you have machine like in the other ones. The most, from the top 10 countries, 7 was from Africa. The first country searching for some artificial intelligence was Ethiopia. And where they are using this kind of artificial intelligence. Here, I put some examples, it could be much more. And what they have in common, besides the huge revenue, they master the data. They use a lot of data to train in the model to make it more intelligent. And of course, University of Valladolid is not behind. Here I try to summarize some of the main topics. Probably the machine learning is the most known algorithm. Also natural language processing for translating and recognize words, text, and computer vision for to create these images, for example, to identify objects, tracking with computer vision, speech to translate the words for text, and after you can use neural language processing for translate for English to Spanish or whatever, and many others. And if you go deeper, we can see that there is a huge word behind each of that topic. And each task here, each algorithm, it's mainly to solve a specific task, or maybe even more than one task. But what this is about the forest sector. The first to start using some kind of machine learning was the remote sensing group, where they tried to identify land use and change, pest and disease, identify species, counting trees, natural regeneration, and many other different approaches. But for me, the most important one, point cloud classification and segmentation, of course. And this is my own definition of point cloud, and I believe it's the way to perpetuate the forest structure. It seems to be really nice. I can scan today, and after 10, 20, 50 years, we can go back in that point cloud and see the reality of the forest structure in that time. So, but how we can transform billions of points in some useful information for forest manager. We need data and analyze the data we have, in this case point clouds. Prepare the data like labeling. You must label all the points and say this is a stem, this is a leaf, this is a floor, a ground, or whatever you want to train. And build a model using one of those thousands of different models. And after you train with your labeled data, you train your model so it can be intelligent and make decisions. And in this case, the decision is to say this is a stem, this is a leaf. It's to classify the points. And after, you must test your data, so you see if the decision the model took was good or not, and deploy. So other person must use this data. Nowadays, I'm using a deployed model. Someone did all the process, and I'm using, but I have the data, I have it labeled, and my next step is to build a new or update this model. And the model I'm using, it's this one. It's a deep learning. PointNet++ was published in 2017, and this is how the structure looks like. And here it's kind of a history of the data. Point cloud, PointNet was one of the first to use this approach of classify points instead of grouping the points, and PointNet++ in the same year. But we have 6 years, and there's a lot of new and more update algorithms to use it. And how can I improved my model? I can add more data and make better data, or I can change the model using different algorithms. Also transfer learning, like using different models to combine both knowledges, or tuning the parameters. This is the approach. But we must be careful, because every time you change something, you must train, test, validate your model, and this can take days for each step. And nowadays, my results using this algorithm, I have 92% of tree detection. DBH is ranging between 2.4 to 3.4 centimeters. Oh, it's meters there, no, it's centimeters. And tree high, I have an error between 1.9 and 3.7 meters. And here is some improvements. We can improve the LiDAR data, the information from the LiDAR. We can train, we can build new models, we can try different tuning parameters. So this is next research and next opportunity for. And that's it. Thank you all.